my name is Naswa, and in this video, I will explain about branch and bound algorithm. Let's start. And I will explain about the definition, how it works, advantage and disadvantage. First, the definition of branch and bound algorithm. What is branch and bound algorithm? Branch and bound is a general algorithm design paradigm that is used for solving optimization problems. It systematically searches through the solution space of a problem, dividing it into smaller subproblems and using bounds to eliminate certain branches of the search tree. This technique is often employed when an exhaustive search is not feasible due to the size of solution space. The key idea behind branch and bound is to explore only those subproblems that have the potential to lead on an optimal solution, pruning the search space as much as possible. This algorithm is commonly used for solving combinatorial optimization problems, such as the traveling salesman problem, the knapsack problem, and various scheduling problems. The effectiveness of the branch and bound algorithm depends on how well the bounding and pruning mechanisms are designed for the specific problem at hand. Branch and bound is a versatile algorithm that finds applications in various domains, particularly in solving combinatorial optimization problems. Here are some common applications of the branch and bound algorithm. First is the traveling salesman problem, or TSP. Given a set of cities and the distance between them, the TSP involves finding the shortest possible tour that visits each city exactly once and return to the starting city. Branch and bound can be employed to systematically explore different tour possibilities and find the optimal solutions. Second, knapsack problem. In the knapsack problem, items with given weights and values must be selected to maximize the total value while not exceeding a given weight limit. Branch and bound can be applied to efficiently search through the space of possible item selections. Third is graph coloring problem. This problem involves assigning colors to the vertices of a graph in such a way that no two adjacent vertices have the same color. Branch and bound can be used to find an optimal or near optimal coloring by exploring different color assignments. And the second view moves to how it works. Here is how the branch and bound algorithm works. First, initialization. Start with an initial feasible solution and an initial upper bound, and create an empty priority queue, or a data structure to keep track of subproblems to store the subproblems to be explored. Second, branching. Divide the current problem into smaller subproblems, typically by making decisions that lead to different branches in the search space, and create subproblems based on these decisions and add them to the priority queue. The third is bounding. For each subproblems, calculate a lower and upper bound on the optimal solution. These bounds help in determining whether a subproblem is worth exploring or can be pruned. If the lower bound of a subproblem is greater than the current upper bound, the subproblems can be discarded, as it cannot lead to a better solution. The fourth is pruning. Prune the search tree by eliminating subproblems that are guaranteed to lead to suboptimal problems. Use the bounds calculated in the previous step to prune the search space efficiently. Fifth, update the upper bound. If a subproblem leads to better solutions, update the current upper bound with the new solutions. 6. Termination. Continue the process until the priority queue is empty or a termination condition is met. 7. Optimal solution. The final optimal solution is the one with the highest objective value among all the explored subproblems. And the third is advantage. First, optimality. Branch and bound guarantees optimality in the solutions it finds. as it systematically explores the entire solution space. Second, versatility. It is a general algorithmic framework and can be applied to a wide range of combinatorial optimization problems. Third is memory efficiency. The algorithm can be implemented to use memory efficiently, storing only the necessary information for the subproblems being explored. Fourth, flexibility. Branch and bound can be tailored to specific problem characteristics, making it adaptable to different types of optimization problems. Fifth, applicability to large problems. It is particularly useful when the size of the solution space is large, and an exhaustive search is impractical. Sixth, pruning mechanism. The bounding and pruning steps help in eliminating portions of the search space, reducing the number of subproblems that needs to be explored. 4. The disadvantage. First, complexity. The design and implementation of the bounding and pruning mechanisms can be complex and problem-specific, requiring a deep understanding of the problem at hand. Second, difficulty in estimating bounds. Calculating tight bounds for subproblems can be challenging, and the quality of bounds directly affects the efficiency of the algorithm. Third, dependence on problem structure. The effectiveness of branch and bound depends on the nature of the optimization problem. In some cases, alternative methods might be more suitable. Fourth, exponential time complexity. In the worst case, the time complexity of branch and bound can still be exponential, especially if the bounding and pruning mechanisms are not effective in reducing the search space. 5. Memory usage. Depending on the size of the solution space, the algorithm may require a significant amount of memory to store in the priority queue or other data structures for managing subproblems. 6. Sensitivity to initial solutions. The algorithm's performance might depend on the quality of the initial solutions and how well it guides the search. And thank you for watching and see you on the next video.